In this lesson we will learn what is an electrode potential and how it is measured. For that, first we need to understand what is an electrode. An electrode is a solid electrical conductor that carries electrical current into non-metallic solid or liquid or any other material. So the main thing is that it is a conductor. So here we will take an example of any conductor. Let's say a copper. We know that copper is a good conductor of electricity. Okay, now how this solid conductor become an electrode? The answer is very simple. When this solid conductor dipped in a solution containing its own ions. Okay, let's see what happens when we dip. Okay, what happens when a conductor dips its own ions? When the metal is in contact with metal ions, the two reactions start. Number one, the ions of solution gain free electrons of metal and get deposit on electrode. Here, these ions will gain the free electrons of metal ion and they will get deposit on that electron. The first reaction is that, and the second one is that the metals start dissolving, producing ion by losing electron. We can say the opposite reaction of that this metal start losing electron and becoming a ion. A metal start losing electron and becoming an ion. Okay, now this tendency, the tendency of a metal to lose or gain electron, is known as electrode potential. Okay, we have two kind of situation here. When it loses electrons, it is called oxidation potential, and when it gain electrons, it is called reduction potential. And the whole assembly, we call this as a half cell. Now this is a half cell of copper. Okay, now let's talk about how to measure this electrode potential. When we talk about the measurement of the electrode potential, it is impossible to determine the electrical potential of a single electrode. We have to use a reference electrode, and the electrode that we use as a reference electrode is called standard hydrogen electrode. In short, we call this SHE. Okay, what is the construction of standard hydrogen electrode? It is the standard hydrogen electrode consists of a platinum plate. This is the platinum plate immersed in the 1 molar solution of sulfuric acid. So we will have a solution having H plus ions having concentration of 1 molar, and this platinum plate is basically inside a glass tube, and in this glass tube a current of pure hydrogen gas, basically hydrogen gas, is pumped at the pressure of 1 atmosphere, and basically it is passing through the glass tube and it will strike on that platinum plate. What will happen? The platinum absorb hydrogen gas on its surface and the platinum coated with the hydrogen. So it will behave as if it were made entirely of the hydrogen. So this platinum electrode will behave like a hydrogen electrode. This whole assembly is called half cell of hydrogen electrode, and the electrical potential of this standard hydrogen electrode is set as 0 because we will use it as a reference. Okay, now how we will use this to measure the electrode potential of the other half cells? First we will take the half cell of copper. Here we are taking an example of copper cell. Then we will take the half cell of copper and we will join this half cell of copper with standard hydrogen electrode with the help of wire, and we will also connect the voltmeter to check how much potential is producing by this cell. And to connect these two half cell, we will use a salt bridge. When we use the salt bridge, then what will happens, we will see the flow of current. The voltmeter tells us two things. Number one, the direction of the flow of current, and the second, how much electrical potential is moving on. Okay. Here we can see that hydrogen electrode, the standard SHE, is losing electron and it is gaining electron. So we will mark the hydrogen electrode as an anode because it is losing, oxidation is going on. And for copper we will mark it as a cathode because the reduction is going on. Okay, now let's see what kind of reaction are going on. As we know that in a hydrogen electrode the oxidation was going on, so it means the hydrogen gas was oxidized to hydrogen ion, losing 2 electron. And we also know that the electrical potential was set 0 volt because we are using as a reference electrode. And on the other hand, at copper electrode the reduction was going on. The copper ions were gaining electron, becoming solid copper, and the electrical potential we have seen from the voltmeter, that was 0.337 volt. Okay, when we join these two reactions, the overall reaction we will get that copper, this is the overall reaction. If we want to calculate the electrode potential or electrical potential of a cell, and we will subtract the value of electrical potential of anode from the cathode. Here we can see the value of cathode is 0.337 and the value of anode that was set previously 0. So then we will get the electrode potential is 0.337. Okay, this is the electrode potential of copper. Thank you.